And here's the video solution for problem 7.16. Okay, in this problem we're given a large number of barrels of oil per day. Okay, so we have 15 times 10 to the 6th, so 15 million barrels of oil. Okay, and what we're doing is we're assuming that we have a cylindrical tank, albeit it's going to be a really big tank. We're trying to store all the oil, and we're saying the base of the tank should be 50 feet across. Okay, so that was also given here. All right, so what we're wondering is how high would this need to be to store that many barrels of oil? Okay, so we're going to find H. Okay. All right, so we have a couple of things we need to worry about. Number one is you need to know how many barrels of oil, what's the volume of a barrel in barrels of oil. So you can Google that and you can find that there are 42 gallons in a barrel of oil. Okay, so from there we're going to need to convert volume into cubic feet so that we can find the H in feet. Okay, all right, so we know that the volume is going to be 15 times 10 to the 6th barrels of oil. And then we're going to need to do a conversion where we know that in one barrel there are 42 gallons. Okay. Then I'm going to need to know how many gallons there are in a cubic foot. And it turns out you can Google that. You can find that 7.48052 gallons in a cubic foot. Okay, so we see our units become consistent, and we have an expression for V. So we can calculate that number and store it in the calculator. Okay. Next, we need the volume of a cylinder, and that would be pi r squared times h. Okay. So we know a few things. We know that r is 1/2 of the radius, and the radius is given by the base. So r is 25, and that's in feet. So we're already in the right dimensions because volume is in cubic feet. Okay, we know the value of pi. We know everything we need to know. We can now solve for h. So V is known. Okay, we simply divide by pi r squared. R is 25. Plug that in, and you get the answer. Okay, so use your calculator at that point. When I do those calculations, I get this to be 42,892.25. Of course, that's carrying way too many significant digits. This would be in feet. Okay, so our final answer using the proper number of significant digits would be, looks like we're carrying 3 significant digits in this problem. Okay, and so using 3 significant digits, this would be 42.9 feet. Okay. All right. Next, in part B, we were asked to find, suppose you wanted to have a cylinder as tall as Mount Everest, what would the diameter of the cylinder be? And we're given the height of Mount Everest to be 29,028 feet. Okay, so we go back and we know V, this is for part B, all this was for part A. B, for part B, we have pi r squared, and now h is known. And we solve for r. Okay, so r would be the square root of v divided by pi divided by 29,028. B we knew from the previous step. We plug that in, and we get an r value to 3 significant places of 60.8 feet. Okay, so there's the solution to problem 7.16.